This podcast is brought to you by the Environment Institute at the University of Adelaide. For more information, visit our website at www.adelaide.edu.au/environment.
I'm very glad to be here because it's a great honor to be together with these great guys who did a wonderful job worldwide, because this is a very, very well-known project all over the earth, the Otway Basin project. And we are the cousin, and we are, if you take in age, 4 months later with injecting CO2, but it's also down there. I don't want to go into all details, maybe 3 or 4 slides only. I will hang on a little bit. That's where the carbon is today. 800 gigatons in the atmosphere, 40,000 gigatons in the seas, and 55 million gigatons in rocks. And we put per year approximately 1 gigaton into it. And if we do a proper job, then at the end, it should look like that downstairs. We will have a lot solved in saline water. We will have part of it reacted to rock, to minerals, and only a little bit will remain as gaseous phase beneath the caprock or in these fluid-filled areas. We also have a lot of partners. We also have projects where we cooperate or collaborate. Ketzin is close to what we nicely call mega city, a bigger city here. Not from the area, it's the same area than Adelaide approximately. We have there also sandstones. Many people think CO2 is stored in big caverns. No, it's the small pore space which are filled with water, and you can pump in CO2, and at the end, the physics is the same in Europe than in Australia. You will end up with 30 to 40%, and these are the 30 to 40%, which is the oil you cannot get out of the pore space. It's the same, even if you want to get it out, it will stay down there. Some will be solved in water, like in sparkling water. You have CO2 solved in water, and with increasing temperature and salt content, this decreases. That's bad for us, but it enhances the density, and so there will be some movements. And then you can generate wonderful minerals. If you use, for example, olivine, which is the simplest one, then you get exothermic reaction for all minerals where you have magnesium, iron, and silicate. And you simply produce carbonates. It has one disadvantage. It generates also this SiOH4, or I called it here SiO2, which is much simpler, and it covers the surface, so the reaction becomes slow and slow and slow. So this needs long times. The Otway project and the Ketzin project had one common thing. We were the only one which made risk assessment prior to the storage. All the others experiment, they simply stored, not thinking about a real risk assessment. Seismic risk, we looked at the cores, we looked at our anticline, we compared it to a 3D seismic, we made lab experiments on these rocks with CO2, what will happen. We make a risk analysis scenario, and there I want to stay 2 or 3 minutes. That's one of the longer slides. When we pump CO2 in the underground, the first thing many people think is CO2 is poisoning because it's an environmental poison. But sometimes we drink it. The second thing people think, you can burn it. I'm very glad you are laughing. Scientists are laughing, but there are many people think if you put something underground, a gas underground, it will be a burning gas. All the other is foolish. But if you have here running around, even there on top, there is a fire extinguisher with CO2. So it does not burn, it makes the opposite. But there is a risk. If you have too high CO2 concentration, it's like being underwater. You cannot breathe anymore. So the risk is if you have a basement and CO2 comes in slowly, then you have the same results as if you produce wine. And you need the same precautions than if you are a wine producer. If it's on the surface and if you have a slight wind, nothing will happen. In Ketzin, the major risk is that journalists visiting the site will have an accident. The second biggest risk is, or the only in this case, is that some CO2 will bubble up the well. But there we have a basement which is filled slightly with water, and we will see if it's bubble, and we measure it with CO2 sensors and so on. But the highest risk that you release CO2 out of such a structure is the well itself. So we have carefully to look at the well. We have also faults. You have seen it on the slides before, and there many people think a lot will go through. We know in Ketzin it's a closed well. It has a very low permeability. But let us calculate as if it would be open. We simply make it open, put coarse-grained sand in, and calculate what will happen. After 50 years, the CO2 will end up in another layer, in this one, which had been an old gas storage site. 10% in 50 years. In another 50 years, it would be 1% in the groundwater. So we need monitoring to see about the risks. But these are the risks we could identify and we could work on. And after we have identified, it's the same. Physics is the same. Permission procedure is different. So these are the permission for an experiment. We did simply an experiment because we pump CO2 down, same as in Otway. We want to learn more about monitoring. Also, the drill rig look equal. The only thing you see at the end is the installation for our CO2 tanks because we have no pipeline. We make hydraulic tests. We make some monitoring. The monitoring was explained quite well. We did some 2D, 3D seismics, geoelectric measurements, temperature measurement, flux measurement, gas measurement. We also have had problems. Our formation didn't want that we pump something in. Did you know that there is life in 800-meter depth? It's more life beneath the surface than above. If you dig 1 meter down and then you go deep down, you may have 100-fold the biomass than above. And they liked our drilling. They eat the drill mud. And they produced due to different reaction sulfides which blocked our screens. We pumped it out. We learned a lot about deep biology. Okay, we did seismic. It looks everywhere the same. It's beautiful, isn't it? We have a valley. We have also these kind of Veloc data. We also make 3D seismic. We look at the cement and how it degrades. I don't want to go into detail, but cement you have to look at. So that's a gas storage. So I go skip so that we have more time to discuss afterwards. That's the same plant, injection facility. Okay, oops, that's the wrong way now. That's another project, so I skip this. Let's go back to Ketzin. We started injection, and now I will teach you something about how to look at data. No, I don't teach you. You know this already. This was the start of CO2 injection. The green line is the CO2 flux out of the ground. We measure 60 centimeters in the ground, and when we started to pump in CO2 in 800 or in 650-meter depth, the CO2 decreases the flux. If we had started this way and we could tell everybody we saved the world, we reduced CO2. But that's not the truth. If you start in winter time, it goes up. It's the opposite than here in Australia, I'm sure. Physics is very different here because summer and winter are changed. If it's cold, the microbes don't make biocenosis. If it's hot, they do. That's simply a temperature effect. And the size of the symbols would be more than 1% of the CO2 we pump down. On a 3 by 3 kilometer area there, you get 30,000 tons of CO2 out every year. So it's not measurable. So we did the same YouTube-like thing. It's a little bit different. If you want to learn more about the differences, simply come tomorrow. We will have some discussion about how to optimize monitoring. If you see here something, I don't see a lot of things here. Seismically, we have big problems to see anything. We use the resistivity log. We put it outside the wells. I guess that's the difference to Otway. And you can see here how after injecting CO2, the resistivity goes up. If you are interested in more details, simply come up after the talk. And we can see that it's going along like in a river, the CO2. So you can monitor, you can observe, you have to deal each site differently, you have to monitor each site differently, and you have to be very careful about that. And the big difference to many other storage of waste and etc. is as longer you wait, as more secure the storage will be. Because the process like solubility, like mineral trapping, or this trapping the residual in the pore space will increase. And I have a simple experiment here. This is how CO2 storage works. You can also use sparkling water, but it's not as fun. And now I'm working now against law because here it's written no drinking, but I guess it's beyond this line here. Do you know, if we want to pump CO2 into the underground, how much pressure we need to pump it down in Ketzin? Do you know how much pressure is in champagne, in a bottle of champagne? German law says it needs to be at least 7 bars. That's the pressure we have also in. And it's held by this few millimeter of glass. The rocks we have above are denser, have a lower permeability than concrete. But the problem is we have pressure, and I don't know if it works. With my broken fingers, I cannot do it. Can you open it? It should make bang. So the tricky part is perfect. So the tricky part is we destroy the cap while drilling through. And if you have ever made a hole in such a bottle and then tried to make it with chewing gum or something like that dense, you'll get into troubles. So that's the tricky part where we learn most at the moment. And then we have something water, or here it's something else in like water, I guess it's yellow water. It's not sparkling water. What did they tell me? Okay, if you look next time when you drink champagne or sparkling water, the CO2 doesn't move along the glass. It goes straight through. And that is what John mentioned before, the wetting behavior. Water wets the glass much better than the CO2 does, and therefore it's kept in the pore space. So you can see this in here. If it doesn't work, simply take a tissue and wrap it out, then it works much better with the whole thing. And many people think CO2 is very poisoning, very risky, so I thought my colleagues and I could make a self-test proving you that CO2 is very dangerous. If you put your nose here, you have 100% of CO2 plus a little bit of flour. So John, come on. That's my way to say thank you to these great guys here in Australia, which helped us from the beginning. This guy, Peter Cook, here was several times in Potsdam. We discussed many issues, and I'm here to learn a lot from the Australian cousins here. Cheers.